To have a vertical tangent, we want our slope to be undefined, so our derivative. So dy dx for polar curves is dr d theta times the sine of theta plus r times the cosine of theta over dr d theta cosine of theta minus r sine of theta. So here, let's find dr d theta. Dr d theta is the derivative of this. That's 3 sine squared of theta times the derivative of sine, which is cosine of theta. So if we plug that in here, we get 3 sine cubed of theta times cosine of theta plus sine cubed theta cosine theta over, and then down here we get 3 sine squared theta cosine squared theta minus sine to the fourth of theta. So our numerator is just 4 sine cubed of theta cosine of theta. Our denominator, we can factor out a sine squared. Let's go ahead and do that, sine squared of theta. And we're left with a 3 cosine squared theta minus sine squared theta. We can cancel out 2 of the sines. We have 4 sine theta cosine theta over 3 cosine squared theta minus sine squared theta. Now we want this to not be defined if we want a vertical tangent, meaning we want our denominator, 3 cosine squared of theta minus sine squared theta. We want that to equal 0. So let's add sine squared to both sides. And then let's divide by cosine squared. We get 3 equals tangent squared theta. So, taking the square root, we'd get tangent of theta is plus or minus the square root of 3. And that happens in lots of different places. That happens when theta is pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3. In fact, it's these two plus k pi. So pi over 3 plus k pi and 2 pi over 3 plus k pi. Those are the values of theta for which we have vertical tangents. And we would just need to know what sine cubed for each of those are. So for pi over 3 and 2 pi over 3, and any even pi after that, the sine is a positive square root of 3 over 2. And so if we want to do that, we'd have, well, positive square root of 3 over 2 cubed would be 3 to the 3 halves over 8, and then pi over 3 plus k, or sorry, plus this is the evens, so plus 2k pi. And it's the same thing for the 2 pi over 3 plus 2k pi. And it's negative if we have an odd there. And so it's negative 3 to 3 halves over 2, or sorry, over 8, and then pi over 3 plus 2k plus 1 pi. Or the last one, negative 3 halves over 8, 2 pi over 3 plus 2k plus 1 pi. Once again, I think this, if you were just state this, of course that encompasses the information with the function r.